Hi everyone, welcome back. Today we're solving pyramid transition matrix. So this problem description is quite long, but I'll just explain through examples. So basically we will be given a bottom string and that will be the bottom of the pyramid. And we want to look through the allow patterns. So what allow tells us is the first letter in each string will be the left bottom. The second would be the right bottom, and the third letter would be what can be go on top of it. And if we can make a pyramid out of the floor and allowed inputs, then we return true, otherwise we return false. So if we look at these examples for BCD, we can put C because of BCC here, and then we can put E because of CDE here, and we can put A on top because of CEA. So then we can return true. And for this example, we have AAA, and as you can see, there is no way that you can build it up to a pyramid because of the last letter up here. You feel free to try it out if you can, but it will take a while to try all inputs. But just know that for this example, it would be false. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use DFS, and we will search through the bottom string, and our goal is to make sure that we can get to a point where there can be one string at the very end, because that would be the top of the pyramid. If that is the case, we can return true. If that's not the case, we can return false. So what we can do first is we can make an adjacency list where for the keys in the tuple, the first one will be the left bottom, the second would be the right bottom, and the value would be a set of the potential strings that can go on top of it. And what we will do, we will look through a set of 2 consecutive characters at a time, and for each of these set, we will look at the potential letters that can go on the top, and then we will set top to that, and then we will iterate in a nested for loop first. So it will be top layers as the outer for loop, and top will be the inner for loop, and then we will add each string from top layers to each character at top. And after we are done with the nested for loop, then we will set temp to top layers, and then we will look again for the next set until we are done with this entire string. And we'll continue that until we can either get to a string of length 1, which will return true, or if we cannot accomplish that, then we return false. So let's go through this example real quick. So first start with BCD. B and C can go at the top, so we set top to that. Now we will loop through for each in top layers, and then this as the inner for loop. So then we will add BC to temp. So first B, then C, and now we can set top layers to this. Now we look at the second set. E can go at the top, and now we will add everything in top to top layers. So E to B and E to C, and now we'll set top layers to temp, and now we can build upon this top layers. So we will first look at BE. Now with BE, there's nothing here, so we know that BE would not work. So now we can look at CE. So let's see CE. We can have A at the top. We will add A to temp because we will iterate through this nested for loop and set top layers to A. And now we look through A. A has a length of 1, so we can return true for this example. Now the time complexity of this problem would be O of 6 to the nth power for both the time and space, because if we look at the constraints of the problem, we see that there are 6 possible letters, meaning that for each layer, there will be 6 to the nth power of possible combinations. So which means it will take 6 to the n time at worst case, and the adjacency list will take up to 6 to the n space at worst case. So now let's get to the coding part. So first, we'll set up an adjacency list. So default dictionary of set. Now for the left, the right, and the top in allowed, we will set the left and right as the keys, and we will add top. And then now we will define a function called add neighbor of node. So this will be the function that works on the potential possible top layers. So first we will set result to empty. Now we will loop from index 1 to the length of it, and for the top characters, like I said, we'll take 2 at a time. So adjacency list of node of I minus 1 and node of I. And if we find any potential top characters, then we will do the nested for loop. So temp for empty array. Now we'll loop through result. So for string in result, for character in tops, temp can append s plus c, and we will temporarily set result to temp, and then otherwise we'll just return an empty string if nothing can go on top. And finally, we'll return result for that function. And now we can define our DFS function. Oh, and we'll also set a visited set just for caching so the time could be faster. Now define our DFS node. So if the length of node is 1, then that's it. We can return true. And if we see node invisited, then we can return false. Now we will loop through the neighbors. So for next and add neighbor of node, that's the potential neighbors. And we will search through it, see if we can move on from there. And if it works, then we can return true. Otherwise, we can add to node invisited and return false. And finally, we'll return DFS of bottom. See if it works. Okay, perfect. Thank you all for watching. Hope this was helpful. If you have any other questions or comments, feel free to leave them in the comment section, and I hope to see you all again soon.